Welcome to the FRC Java programming course. This is the second course in the series for Java programming in the FIRST Robotics competition. In the last course, Introduction to Java, we went over the fundamentals of Java programming. That course did not go into very much FIRST specific content, but it did cover the fundamentals that you will need if you're going to be successful in FRC programming. In that course, we looked at the language basics, how to declare a class, how to declare methods and attributes. We looked at the fundamental principles of object-oriented programming, encapsulation, abstraction, inheritance, and polymorphism. We also went over program logic. That included statements, expressions, operators, the order of operations for operators, how to invoke methods, control flow statements, and enums. We also looked at inheritance, error handling, and we also looked at coding standards that programmers have developed over the years that make their programs more robust and easier to read. Lastly, we looked at documentation. Specifically, we looked at the Javadoc system of embedding your documentation into Java comment blocks along with your code in your .java files. So now that that's under your belt, we're going to take a different approach for this course. This course will be a little more interactive, looking at the actual tools that we're going to use for the Java programming. We're also going to actually develop code for a sample FRC challenge, one that's representative of the kinds of things that FRC will do, but is not likely to be something we'll run into in future years. Okay, Module 1, we're going to review the Java environment. FIRST releases a new set of tools every season for the FIRST Robotics competition. Basically, it's the same thing year after year, but they tweak it slightly from year to year. Right now, when this course was put together, we've completed the 2017 season, which was the Steamworks game. So, in order to perform software development for the FRC, the first thing you're going to need is a computer. That can be a laptop, that can be a desktop computer. It can be a student's computer, or it can be one of the computers that's provided by the school or by the team. On that computer, you'll need to install Labview. FIRST distributes the Labview software to the teams, and currently, as of the 2016-2017 year, it would come on either a DVD or on a thumb drive. Usually, they'll accompany that with instructions to go to the FIRST website that will tell you what you have to do. If it's a new version, you may have to uninstall the old version before you install the new version. Some years it's just a patch update and there's no uninstall or reinstall required. So I would encourage you, when you get the new challenge, to read the documentation. Go to the FIRST website and read the software tools documentation on how you go about installing it. The reason Labview is required is because many of the utilities that FIRST uses are actually developed in Labview. So the driver station is one of those pieces of software that you'll need to have on your computer during the competition, and that software requires Labview be installed. The RoboRio also provides a web-based interface. So in order to interrogate the properties of the RoboRio, as well as to update the firmware that is installed on board the RoboRio, as well as updating the firmware on some of the modules that are provided as part of the FIRST competition, you'll need a web browser. In 2016 and 2017, that web browser required the Silverlight plugin, and the web interface to the RoboRio was all developed in Silverlight. I believe they're moving away from Silverlight for the 2018 season, but time will tell. But you will need to go to the FIRST website and read the documentation. Almost certainly there'll be new firmware available for either the voltage regulator module, the pneumatics control module, or for the RoboRio itself, and possibly for motor controllers like the Talon SRX motor controller. So in that event, you'll need a web browser on your computer that will allow you to connect to the web interface on the RoboRio. The third thing you'll require on your computer is an integrated development environment. Right now, FIRST is using the Eclipse integrated development environment, and In my last programming assignment, actually, let me rephrase that. In my last 2 programming assignments professionally, we have used the Eclipse environment. So this is not a dumbed down environment that's used just for students. This is the same environment that professional programmers are using on the job to develop software. Obviously, whatever computer you use will need to have access to a RoboRio. That can either be done through a USB tether, that can be done with a Ethernet tether, or that can be done over Wi-Fi once the RoboRio is configured and the radio is configured. Regardless of how you do it, you will need a network. You can deploy your software using a wired or wireless network. Just one point, the FRC environment has been using micro DNS starting in 2016. What that means is your RoboRio can have an IP address assigned dynamically. Every time you boot up the RoboRio, it's going to seek out a micro DNS server, and once it finds that server, it's going to connect to it using the Dynamic Host Control Protocol, DHCP, and ask that server what IP address it should be on at that moment. When you power off and power back on the RoboRio, it can get a different IP address, but you'll always be able to access it using its DNS name. You can still, as of the 2017 competition year, you could still use a static IP address. The reason you would use a static IP address is because you have some other networking equipment on board your robot that doesn't speak the micro DNS protocol. Most often that would be an access camera or some other device, maybe an Arduino or some other custom electronic circuit that is connecting over the wired Ethernet to a switch, and the switch is connecting to the onboard radio. So again, read the rules when the new competition comes out, find out what networking environments are legal, they can change from year to year, and figure out what you're going to need. If you do need to use micro DNS, it will be included as part of the driver station software. Or let me rephrase that. It was included as part of the driver station software in 2016-2017. It could be deployed as part of a different piece of software in the future. The number 1 rule, read the documentation. So the Eclipse IDE is an open source, cross-platform, and cross-language IDE. So you can download Eclipse for Java development. You can also download it for C or C++ development. I think you can download it for PHP development and probably some other languages as well. You'll need the Java development kit for Eclipse in order to compile Java. The Eclipse IDE uses the Java development kit that's already on your computer. The easiest way to set up your environment is to go to the java.oracle.com website and download the Java development kit for your platform. First uses, at least as of 2017, first uses the standard edition of Java. So that would be Java SE. Once you install the JDK, you can install Eclipse. Part of the Eclipse configuration process is to make sure it's pointing to the correct JDK. It is possible to have more than one JDK on a system, so you want to make sure you're pointing to the JDK that you want to use. Usually that would be the one you just downloaded, which is the latest and greatest, most up-to-date version of the JDK. Once you have Eclipse installed, first actually provide some plugins that you install in Eclipse. These plugins let you deploy code easily to the RoboRio, and they also let you get the console output from the RoboRio back into your Eclipse environment. When you format your RoboRio, there's a checkbox in the RoboRio formatting tool that lets you specify whether you want the Java libraries installed. If you remember back to the introduction to Java programming, the Java compiler is going to compile your program into bytecode, and it will deploy that bytecode in a Java archive, a jar file. The actual execution of your code requires a Java virtual machine be installed on the RoboRio. So when you check that box, what you're actually doing is making sure you install the Java virtual machine on the hard drive of the RoboRio. The RoboRio has a small solid-state hard drive that lets it install all of these files. So what are the good things about Eclipse? The first thing is it's a fancy editor. What that means is it does source syntax highlighting as you type. So if you type in a Java reserved word, just like on the PowerPoint slides that I used for the Introduction to Java Programming course, they'll highlight in a purple color. Comments will either be green or blue, depending on whether they're Javadoc comments or block comments. It will also highlight literals in blue. It'll highlight static methods in italics. So that makes it a lot easier to draw your eye to the part of the code you want to pay attention to. It also does compiling as you type. What that means is, as you type a line of code into the editor, the Eclipse IDE will compile just that one line of code, and if there's any errors in that line of code, it'll warn you. So you don't even need to have your RoboRio around to write the code. You can work on a laptop or work on a home computer at home, install Eclipse, and it'll tell you if your code is syntactically correct. You'll still need a RoboRio to actually execute the code to find out if your program logic is correct, but at least that'll eliminate one source of errors. It also has content assists. What that means is it gives you pop-up lists of compatible methods, attributes, etc. So if you're typing, if you have a class called Steamworks, you could type Steamworks space George semicolon. Then when you type on the next line George dot, it'll give you a pop-up showing you all the methods in George that you have access to. So it's only going to show you the public methods, but once you select a method, it'll actually tell you what parameters that method takes. So again, that's very, very helpful, especially as you're just learning some of the WPI LibJ API. Eclipse has a lot of features for things like easy refactoring. You can jump to a file very quickly with a hotkey, and then you can right-click on a class name and refactor. Refactoring is a fancy way for saying a do-over. It means we're making a change to the way we wrote the code originally. So if you're changing the name of a class in Java, you have to change the statement that declares the class. You also have to change the name of the file that that class is in, because in Java, your source code is always in a file whose name is the name of the class.java. You also have to change every single import statement in every other Java file that uses that class, because in Java, everything must be declared before it can be used. So you can see changing the name of a class could be a multi-step process. Eclipse, you can right-click on a class name and hit refactor and type in the new name, and it'll take care of all that for you, which is a very, very nice feature. Java also has a debugger available, and Eclipse gives you easy access to that debugger. That's beyond the scope of this course, but it will be in a future course. The Eclipse editor also gives you very easy access to the Javadoc. So if a library has the Javadoc documentation, or a library that you're linking to has source code with it, Eclipse will actually let you hit a key which will jump to the Javadoc for that particular method or attribute. The last thing is Eclipse has more hotkeys than you can shake a stick at. I'm not going to go over all of them here, but I would encourage you to go out online and search for Eclipse quick reference guides. A lot of sites have quick reference guides which you can print out, and oftentimes they're designed so that you can fold them up and tuck them into a notebook or tuck them into some other book that you have, so you can keep them handy. Eclipse has a ton of hotkeys. I know Control-Shift-R is one of them that I've used before. Control-G. I mean, there's lots and lots of hotkeys that you can use. So here's a screenshot of what the Eclipse IDE looks like. Rather than looking at an image, I'm going to switch screens over to the actual IDE editor and show you what it looks like in operation. Okay, here I have the Eclipse environment. It's made up of a series of dockable panes. This leftmost pane is your package explorer, and that's going to show you the files and packages that make up your project. As you can see, this is a new install, so I don't have any. The first thing I'm going to do is create a new project. So if I go to File, New, and all the way down to the bottom, I pick Other. And you can see I've already opened WPI Lib Robot Java Development, and I'm going to pick a new Robot Java project. So now it's going to ask me for some information. So I'll call this Sample, and I'm going to put it in the package. In Java, every single class has to be in a package. So I'll say net.single-celled organisms.frc. And now for project type, I'm going to pick sample robot. That's a robot project used for small sample projects or highly advanced programs with more complete control over the program flow. So that sounds good. When I hit finish, I now get a new project sample. And we can see that in my source folder, I have the package net.singlecelledorganisms.frc, and if I open that, I can see there's already a robot.java. The script that was run for me when I created the new package using the FRC plugin created a build.properties, a build.xml, and a couple other files. The important thing, if I double-click on robot.java, it's going to open that file, and I can now see that the code looks fairly similar to the way I tried to style the PowerPoint slides in the previous course, the Introduction to Java. You can see reserved words, package, import, public, class, extends. Those are all highlighted in bold purple. Any local attributes of a class are rendered in blue. So you can see this class has a couple local attributes. It has a robot drive called myRobot. It has a joystick named stick. It has two strings, default auto and custom auto, and then it has a sendable chooser template. So that's a generic programming concept that we did not go into in the Introduction to Java. Lastly, it has a constructor, robot, which is the same as the name of the class, and it's going to set the expiration to 0.1. Next, it overrides robot init, it overrides autonomous, and it overrides operator control. I know that because we're using the @override annotation. Within operator control, we can see that it sets the safety mode to true and it enters a while loop. While is operator control and is enabled. So as long as both of those method invocations return true, we will stay in this loop and we'll invoke it again and again and again and again and again and again. So the first line inside that is myrobot.arcade stick, and then we have a timer delay for 5 milliseconds. So once every 5 milliseconds, we're going to call the arcade drive method of myrobot, passing it stick. So what is myrobot? If I hover over that, it actually shows me the Javadoc. And remember I said every single attribute requires Javadoc. So if we go up to myrobot, that we can put that in. Attribute to control drive motors for robot. And I'm going to put in this attribute. This is a composition association. One of the difficulties in Java is that from a declaration like myrobot, you can't really tell if this association between robot drive and robot is via composition or aggregation. So it's useful to put that into the documentation, into your Javadoc. So now when I hover over myrobot, the yellow pop-up actually shows me the Javadoc documentation that I just created. And we would do the same thing for joystick. Attribute to read human input during teleoperated mode, and so on and so forth. Now, for the autonomous method, there's already some Javadoc that's given to us. This autonomous, along with the chooser code above, shows how to select between different autonomous modes using the dashboard. The sendable chooser code works with the Java Smart dashboard. If you prefer the Labview dashboard, remove all of the chooser code and uncomment the getString line to get the auto name for the text box below the gyro. So you can keep this code or you can get rid of it. It's kind of your preference. What this code does is it's going to put on the dashboard a drop-down box that lets you select whether you want the default auto or the my auto version of your autonomous. It's going to call the getSelected member of chooser and store that in auto-selected, a local variable, and that is used in a switch statement. So in that switch statement we have two case stanzas. We have custom auto and default auto. Those are the values of the string. We also have a default stanza. Remember, in a switch statement, the stanza continues until we hit a break statement. So the first case, custom auto, extends all the way until this break statement. The next one, case default auto, extends to this break statement, but default also extends to that break statement. So what that says is that both case default auto and default execute the exact same code. Another way of phrasing that is default auto is the default. So if you don't pick something else, that's what you're going to get. Other features of the Eclipse editor, we have over here on the right hand side we have an outline. Once your classes start getting large, hundreds of lines of code, you can use the outline to jump quickly within a file. So I can say I want to go to custom auto, I want to go down to test. So it scrolls the window to that particular item that you've just selected. So it's a quick way to navigate. Other ways of navigating, you can hit F3 or you can right click on any attribute. So let me pick my robot down here in the autonomous method. I can right click on it and say open declaration or hit F3. F3 is one of those hotkeys. And that'll take you directly to that declaration. If you've installed the WPI Libj software with source code, you can also right click on other people's classes and same thing, open declaration, and you can now see the code for the robot drive, and this is in the WPI Libj package. So you can see all the code that WPI Libj has provided to you. You can also use the outline to navigate your way through their code, and you can see this is where that becomes handy. Stop motor is down on line 723, and I can skip around just by clicking on this outline. Another handy feature is I can highlight any of this code, like joystick, and I get the Javadoc. So you can see the documentation for this class. Handle input from standard joystick connected to the driver station. This class handles standard input that comes from the driver station. Each time a value is requested, the most recent value is returned. There is a single class instance for each joystick, and the mapping of ports to hardware buttons depends on the code in the driver station. So it gives you some overview about how that class works. I mentioned earlier that if we are overriding a class that is the same signature as a class in a base class, we always want to use the @override annotation. The reason for that is because it'll throw an error if we have a simple spelling error. So I'm going to change this. Instead of operator control, I'm going to change it to operator control. I took out the T. And you can see there are now red squigglies underneath that line of code, and I've got a big red X over here in the margin. The red X says the method operator control of type robot must override or implement a supertype method. That's the message that @override annotation gives you. It's very easy when you're writing code, especially if your blood pizza count has gotten low, to inadvertently fat finger a method name or an attribute name, or possibly screw up some operators or parentheses. So the ability of the IDE to do just-in-time compiling of a line of code, one line of code by one line of code as you're typing, is pretty handy. Okay, so how do I deploy my code? I can right-click on the code and I can hit Run As and hit WPI lib Java deploy, or the plugins added this button to the toolbar which has the same option, WPI lib Java deploy. Selecting that option is going to do a couple of things for you that makes your job a lot easier. First thing it does is it's going to automatically compile your code, so it'll compile your Java source files in your .java files into bytecode in .class files. Next, it's going to archive all of your .class files into a Java archive, a jar file. Third, it's going to transmit that to the RoboRio. Fourth, it's going to unpack the jar in the correct directory on the RoboRio. And fifth, it's going to invoke your Java code on the RoboRio using the Java virtual machine that's been installed on your robot, on your RoboRio. So that's incredibly powerful, and you're going to be using that a lot. So lastly, I have the Rio log available. The Rio log will actually display any print statements that your Java code on the RoboRio produces. So if you put any system.out.printlns in your Java code, which is a useful debugging technique, that output will show up here on the Rio log. So again, that's a useful plugin to have enabled, and you can go to the first documentation to find out how to enable it. So that's our quick introduction to the Eclipse IDE. As we get into the later modules, we're going to be using it in much more detail. So hopefully this is just going to whet your appetite, and we're going to get into many more features of the Eclipse IDE as we go forward. Thank you for attending this class, and I hope to see you at the next class.